continue. This is Unit 8, and it's how many states can you name, and we're going to be constructing a 95% confidence interval, so we're going to continue on this particular lesson. So the first thing, it says, how many states can you name in 1 minute? Consider this class to be a random sample of all high school students. Construct and interpret a 95% confidence interval for the mean number of states a high school student can name in 1 minute. So what we did in class is that I had every single person basically write down or name to each other, timed 1 minute, and then the other timed 1 minute or said the names of the states, and found how many states you could name in 1 minute. Then we found we had 26 students, so that's why n is equal to 26. The mean states was 16.15, so we added up them all, divided by 26, and we got 16.15, and the standard deviation was 2.99. And then when we graphed it, this is what we got. So each dot represents one student, how many one student could name. So one student could name 10 states, another one could name 12, 3 of them could name 13, and so forth and so on. So if we fill out the parameter, remember the mean is mu, and it's equal to the true mean of states a high school student could name in 1 minute, really that should say. And I'm doing a confidence level of 95% because that's what it asked me to construct, a 95% confidence interval. And so my plan here, I'm going to do a 1 sample t interval for mu, or for my mean. We got to check our 2 conditions that we've been doing, which my random. It did say consider this as a random sample in my startup. And the normal or large sample, the sample size is small because I only have 26 and that's less than 30. So if it's small, you have to check if it's no strong skewness or outliers. And if you look at the dot plot, it's pretty symmetric. There's nothing crazy going left or going right. So we're okay, because the whole idea of n greater than 30 is that guarantees us that my distribution is going to be relatively symmetric, and I can continue with the formulas because I need an approximately normal distribution in order to continue with my formulas. But if it's less than 30, all I have to do is graph it and make sure that we're okay, and we are. All right, let's go ahead and continue. You can definitely put this video on pause if you need to catch up. So since the conditions are met, we can continue to do the calculations. And remember, the general formula for any confidence interval is the point estimate times the margin of error. My point estimate, remember, is just about the estimate what I think it is, which is 16.15. And the margin of error, if you remember from yesterday's lesson, is this formula, x bar plus or minus t star times s over square root of n. Now, 95% confident. And my degrees of freedom, remember the degrees of freedom when we had, remember how I just explained degrees of freedom? If we have 4 numbers and I want you to add them up, you can choose any 4 numbers, but the catch is that they have to add up to 100. So if I first number if I choose is 50. Second number I choose 25. Third number I choose 10. So 50 plus 25 plus 10 is now I'm at 85, and the fourth person must choose 15 because I said it has to add up to 100. So I was free to choose my 3 of those numbers because I had 4 numbers that I was choosing, but I had a limitation that it had to be 100. So my degrees of freedom is minus 1. So I have 26 students, minus 1 is 25. Why is that important? Because when I go to my formula on my calculator, which we're going to go ahead and bring this up, go ahead and bring your calculator up. Make sure you have a calculator out and you're actually doing this with me. Menu, stat, and you're going to go to distribution, and I'm going to go to inverse t. Just like we found the z star with inverse norm, inverse t is how I find the t star. Now, 95% is the 90% in the middle, but it's kind of shifted over a little bit, so I'm saying, hey, it's shifted over how much? By 0.025, so I have to do 0.025 plus 95, which I've seen people do this, which it's 0.07, or you can write it out as 0.975. That's what I need. My degrees of freedom, as it said, is 25 because there were 26 students, and that's where I'm going to get 2.0595. Now, if you did it in the chart, it's going to be slightly different. You can do it from the chart, but it is still about 2.06. So you can see where these numbers come from. X bar is 16.15 plus or minus the t star I just found, 2.060. Standard deviation is 2.99 divided by square root of n, which is 1.26. So this is 16.15 plus or minus 1.21. And if I go ahead and do the confidence interval, I subtract 1.21 from 16.15, and I get 14.94, and then 16.15 plus 1.21, and I get 17.36. So my conclusion is we're 95% confident that the interval from 1494 to 1736 states captures the true mean number of states of a high school student that can name in 1 minute. So guys, what I'm saying is if I ask 100 students, then we are 90% confident that out of the 100 students, that if the true mean is going to be contained in between 14.94 and 17.36 states. If I had 100 confidence intervals, excuse me, I said that backwards. Of 100 confidence intervals, the true mean would be contained in 95 of those. All right, so remember the conditions. We've talked about these before, that the population has to be approximately normal, which we said. The sample size has to be bigger than 30. And then if the sample size is not bigger than 30, this is not a new condition. This is just kind of a sub-condition of 2. You have to graph it and show there's no strong skewness or outliers. So the 4-step process is state, plan, do, conclude. You'll see I have some things called phantoms on mine, which is the same thing. My phantoms is parameter, and then hypothesis, assumptions and conditions, and then you'll see name the test, state the test, statistic, and so it's the same thing as this here. It's just done in a little bit more detailed steps. So this one here, state, is parameter and confidence level. So the one that you'll see, or panic, excuse me, I said phantoms because we're doing something else. This would be panic, which is going to be, for P for mine is parameter, as the same thing. And you'll see A is assumptions and conditions, which is the same thing as here. And then the name, the confidence interval, and then you're going to set it in context. So this is state, plan, do, conclude is the same idea that we're going to be doing. Okay, let's go ahead and I want you guys to see if you can do the confidence interval. So you can plug these data points into your calculator. Now it's going to be on one, don't do 2 columns, do one gigantic column. So you're going to put it all in one gigantic column. And then you're going to construct and interpret a 90% confidence interval for mean equals tension of all screens produced on this day. So I'm going to state it, and so I have the mean is equal to the true mean tension in this particular data, or excuse me, unit of all screens produced on this day. And then it's a 1 sample t interval is what I'm doing because it's a t that I'm using. And it's for means, so check, is it random? Yes, it says it's random, so we have a random sample of 20 screens. It's not large, it's small because it's less than 30, so we have to graph it. But you can see the graph when we graphed it is no strong skewness or outliers. If you don't remember how to graph, remember I'll show you here in just a second. So let's go ahead and do this together. So I want everybody to get your calculator out and let's do this together. So get your calculator. I'm gonna, hold on, let me bring it up. Okay. Hopefully you have your calculator now. So I'm going to bring it up here and bring up a spreadsheet. Oh. So bring up a spreadsheet. Oh, okay, it's saying I have too many open. So I'll just get this spreadsheet and clear it out. I'll just do mine over here. That's fine. Okay, so let's put the data in. 269.5, 297, 269.6. All right, make sure you guys are doing, oh, look at this. It's not even in. Sorry, let me get it in here. Let's see. There we go. There we go. 269.5. There we go. Make sure it's labeled. I'm just going to put label and I'm going to put MVs because that's what we're talking about. So we're going to go there. 269.5, 297.0, 269.6, 283.3, 304.8, 280.4, 233.5, 257.4, 317.5, 327.4, 264.7, 307.7, 310, 343.3, 328.1, 342.6, 338.8, 340.1, 374.6, and 336.1. Okay, so hopefully you did these along with me. I tried to do it slow so that you guys could be able to follow and I had it already put in. So, okay, let's go to menu, stat, test, or excuse me, not test. Actually, I haven't done this here. So no, actually I haven't done these tests here. So let's do this. Menu, stat, apologize, menu, stat, calc. Let's do n variable statistics. And xlist is MV. And then, oh, you know what? I'm on the wrong, no, I'm not. Okay, and then okay. Okay, so this gives me all the data that I need, which is my x bar and my n. So I have 306.32 and my n here. Also, I'm going to need to, oh, it doesn't, it's not allowing me to add a new page because it says so let's just do it from here. I'm opening up a spreadsheet. I'm just gonna delete this real quick so I can open up a new page. So give me a second, let me delete this. Okay, so in doing so, and when I just deleted my whole thing here. So it's clear, but the problem is I delete everything. So I'm not gonna add it up again. I'm just gonna put like one or two just to show you, to make sure you understand how to do it. So you saw the data that I already brought up, but let's just do this. Okay, so if you're remembering how to graph, you're just gonna put, it's gonna hit Control Doc, number 5 for you, and then your data is gonna be here. And so that's what you're going to list, and you're going to add, I don't have anything labeled, so you're gonna just put your data right there. And it will give you your graph. Okay, so that will give you a dot plot that looks like this. You'll draw the dot plot and say, hey, it's good to go. Then you saw that I already got the data, 306.32, the standard deviation of 36.21, and the n is 20. And then you're just gonna put everything in here. Except, of course, I needed to find the t-star, which I haven't yet, which is inverse t. And 90% confidence means you're going to put in what? So you're going to go ahead and go to inverse t. So menu, stat, distribution, inverse t, and it's a 90% confidence interval. So remember, 90% plus the tails, 95, and the degree of freedom for this one, remember we have 20, so it's going to be 19. And it's going to give me 1.73. or 729. And that's where all these numbers come from. Using technology, you see this is what we get, and that we are 90% confident that the interval from 292.32 to 320.32 captures the true mean. All right, the manufacturer's goal is to have an average of 300. Will it meet it? And you can see, based on the interval, is there convincing evidence the screen produces they don't meet it? No, it does meet it. It looks like it's in between it because it looks like 300 is plausible, that it's somewhere between 292 and 320. Okay, I hope that helped, and I will see you soon. And if you have any questions, let me know.